Mass and weight can be a little confusing at first, and introductory math textbooks often don't help. I get why, and we'll talk a little bit about that here, but I still think they could do a better job of making the difference clear. So here's the situation. Suppose you've got a 100 kilogram or a 220-pound weight sitting in your living room. I don't know why, just assume you do. Now, suppose you take that weight and move it to the moon. I don't know how you get it there. I don't know, maybe you got a friend at NASA or something. Now, the weight is still 100 kilograms because kilograms is a measure of mass, and mass is a measure of how much stuff an object has, and that doesn't change no matter where you are in the universe. The number of pounds, however, has dropped to just 36. Pounds, unlike kilograms, is a measure of weight, and weight is really a force. And forces depend not just on how much stuff something has, but how much gravity there is pulling on that stuff. And the moon's gravity is a lot less than the Earth's. Or I suppose we take that object again and move it into space, twice as far from the Earth as the moon. Well, again, the mass is still 100 kilograms, but the weight, okay, the weight depends on the mass of the Earth, it depends on the mass of the moon, it depends on the position of the moon relative to the Earth and the weight, an awful lot of physics stuff, right? So if we set the physics business aside, we'll just say the weight is a really small number of pounds. Okay, so hopefully you get the idea. Mass is constant no matter where you are in the universe, where weight changes depending on where you are in the universe. So, I'll admit, this is a little bit me being a fussy math professor, right? If you take an object from the lowest accessible point on Earth up to the highest accessible point on Earth, the change in its weight is negligible. So it really isn't entirely unreasonable for textbooks to say 1 kilogram is equal to 2.2 pounds. As long as you're somewhere on the Earth, yeah, okay, that's going to be a pretty accurate result. My issue is when textbooks just ignore the distinction altogether. I don't think it's that complicated, even for young students. And with young students, the explanation opens the door to conversations about space travel and life on different planets and other things that a lot of students think are a whole lot cooler than unit conversions. So, if you like this video, please take a minute, click on the like button, and if you'd like to see more of this content, you can click on the subscribe button here as well.